I welcome everybody here. Thank you for joining my presentation. So today I'm going to talk you through a system for unpiggable pipelines, especially challenging pipelines, which works from above ground. So the presentation is basically built up with discussing how the system is built up, the entire inspection. Then we go to recent developments we have done, and lastly, we will talk about the field experience which we have made with the system. So let us start. I'm introducing a system to you today which is a unique inspection technique for challenging pipeline diagnostics from above ground. So we see over here a line, and the line is picked. And unfortunately, the pig gets stuck. Why is that? We all know there are sharp bends, there's too little pressure in the pipeline, they are changing diameters. So we know that 1/3 of all buried pipelines are considered as being unpiggable. There are other reasons. Economically speaking, it doesn't make any sense to insert any pig launchers or receivers in small branches being 2 or 3 kilometers wide. So how do we actually overcome the limitations of inline inspection? We need solutions. So the Electromagnetic Pipeline Testing GmbH is offering such a solution. It's called EITEP, and EITEP stands for Above Ground Inspection Technique. So basically, we have developed an inspection system which measures the magnetic field around the pipeline from above ground. So on the left, you see our sensor array. It's carried by 2 people. And on the right side, you see our data collector module. It's operated by 1 person. So in total, the inspection team consists of 3 people. So over here, you just see a picture, how it really looks in operation. The sensor array in the front consists of 4 lines. Each line holds 6 sensors. So in total, we have 24 sensors measuring the magnetic field around the pipeline. And in the back, we have the data collector module. So how does the inspection look? How is it set up? How much preparation do you have to do as a pipeline operator? So for the preparation itself and for the inspection, a magnetic field is inducted by a specially generated AC current, which comes from our current source within the truck. So we are using existing infrastructure for connecting. So we can use, if the pipeline is run under cathodic protection, we just use CP post, or we can use pipeline parts above ground. Also, we can use, for example, bends which we do excavate. So we do an excavation hole. If there are no CP posts or the CP posts are too far apart, then we just do a little digging hole, remove the coating, and attach a bend and our cables to that. So speaking generally, it's very simple to operate and to prepare. So afterwards, the connection cables are rolled out, and the connection cables are rolled out to parallel to the pipeline. So only 2 connection cables are needed every 1 kilometer. So if you think, for example, about guided wave, where you have to do excavations every 50, 100 meters, we don't need that. Generally speaking, we don't need any excavations at all for the actual inspection. We just need CP posts every 1 kilometer, and we are certified for that. So how does actually the system look in operation? So you see underneath there's a pipeline, and the pipeline looks fine there, and on the right there's a defect. So if you get the guys moving, so you see that the pipeline without a defect has a concentric magnetic field. And simultaneously to that, the data is measured by a sensor array and then will be stored in our data collector module. We use GPS measurements with sub-decimeter accuracy with every inspection step. Why do we do this? First, we make sure that we give you the exact defect coordinates, and secondly, we make actually sure that we can map pipeline routes for you. So if the inspection goes on meter by meter, the inspection steps enable seamless capture. So the pipeline is still fine there, and the next step is going to be interesting. So there's the defect, and we found it. Why do we actually find the defects? Because the defects cause measurable changes in the magnetic field. So there will be deformation of the magnetic field. And if we go a little bit more into the principles of EITEP, you see two cases, case 1, case B. So case A is basically a concentric magnetic field around the pipeline, and the harmonic components, which our inspection current consists of, they're aligned with each other. It changes in situation B as the magnetic field curves are frequency dependent. We have a little spread between the lowest and the highest frequencies we induct into the pipeline. That's why we get a little bit of an eggy shape in the deformation of the magnetic field, and we can localize the defects. So what happens afterwards when we were collecting the data at the field? The data is sent to our MPIT factory. Over there, our experts are working on the actual results, so we develop special evaluation software, and the outcome is a final report. So the pipeline condition is summarized within this final report. So my question to you is, why should you actually use agate? So what makes it special as an inspection technology? First, of course, it's from above ground. So we don't need anything to insert into the pipeline. But if we speak about the defects we find, we see that we can locate internal and external corrosion, blisters, gorgs, dents, mill features. So for us, it doesn't matter which type of defect this is. For us, it matters that there's either deformation in the pipe wall or there's metal loss. So everything what changes the magnetic field will be detected. So secondly, we locate groove welds, bends, and casings. And we locate coating damages and differentiate them from metal loss defects. So why is that actually special? If you think about DCVG or other inspection methods, we can actually say that we differentiate coating features from metal loss because there are two principles used. Because of the inspection current, we can see if there's current leaking out of the pipeline into the earth. Meaning that if the coating is damaged, we see where the coating is damaged. Also, we see the deformation of the magnetic field, so we can see whether there's a metal loss defect or not. So what we can tell you is whether there's a metal loss defect or only a metal loss defect underneath perfect coating, or there's a metal loss defect and a coating feature, or there's just a coating feature. So you can save money with your decisions for excavations. So also, we locate corrosion under despondent insulation, which makes it possible. So yesterday, as we have a booth here as well, we have had the questions, can you actually detect where the coating is despondent? No, we cannot say where it actually is despondent, but we can see if there's corrosion underneath it. We measure the depth of cover with an accuracy of 20 millimeters. And we verify pipeline routes. As already said, we pinpoint defects and we can verify your pipeline routes. So if you're not very sure where your pipeline is located, we do this and it's integrated in our service. So let me just have a little sip of water. So what are the key benefits of agate? So the key benefits of our agate, as already said, no preparation for the inspection is needed. We have no influence on the product flow, so we are clearly non-destructive. Seamless capture and analysis of the pipeline data, and because we are working from above ground, we can do right-of-way inspection for use. So we see actually if there are any obstacles like houses, trees, fences, whatsoever, which might harm the security of the pipeline. So what are improvements? So some might know the inspection technology under the name NOPIC, so the name has changed now, and the name is called agate. So we have made significant developments, and we're coming from the past step, going to the current step, and we want to bring the technology even on another level. So I will talk you through our steps and what we have achieved. So the past state, what was in the past state? Before 2015, the past state was that the inspection technique was very sensitive to magnetic field interferences. So we could only or merely detect large defects. We struggled with old and corrosive coating, and there were no GPS measurements. So especially this was a very tricky point, because when we had 500 meters of plane field and we were using a measurement tape and we located a defect at 276 meters, how is a pipeline operator would you find or pinpoint the actual location of the defect. But since 2015, we have invested heavily in research and development. So the inspection technique has changed significantly. So what have we achieved? So our current status that we have significantly reduced magnetic field interferences. So leading that we can actually detect smaller defects now, and the inspection with all types of coating as possible. So we have created new intelligent algorithms, so we are using artificial intelligence. We have created also a new structure of our current source. Furthermore, we did improvements of the software and hardware, and we automized the calibration of the system. So the system is also more productive now. So now, at the moment, we have just finished the modeling of a complete new variant of the system. And I want to quickly talk you through that. So there are a couple of parameters. And you see the curves over there. And these curves basically see how our system is reacting or responding to our defect, so to our reference defect. So you see BN is for the new variant, and BN is for the old variant. And what you see basically is that the output parameter B for the new variant is 6 to 7 times bigger than in the new variant, which is a giant step for us. So actually, we know all that inspection methods or techniques from above ground, they all have their struggles, and we can do with this step, we can actually change the market. So because we know now that it works, we are prototyping it now, and the new inspection system really ready in 6 months to 1 year. So what does that mean, and what does that allow us? So we can even detect smaller defects, and we can detect, we can do clusterings of defects, which will be very helpful. So if we do a final report, we want to establish an own clustering, so you can make your own decisions as a pipeline operator. Also, the productivity shall be further enhanced. So now we have an average productivity of 700 or 800 meters. It always depends on the ground surface. But then we want to bring it up to 1,000 or even more meters per inspection day. Also, there will be a leasing option for pipeline operators, meaning that now we are a very service-driven company, and we want to become more of a manufacturing company that we actually lease out the system. And we want to have a renewed technical certificate. So now we are certified by TÜV Süd, but we want to renew this, and we want to show that the things we are actually doing, we want to prove them to the market, and we want to prove them via certificates to you. So what is actually the field experience with Agit? As I said, the real development began in early 2015, and since that, over 90% of the diagnosed defects have been verified. They have been verified by excavations, so we can actually say that the system has proven its reliability to the market. So we are very happy with this new development. So I would just want to make an example of the defects which we can detect from above ground at the moment. So you see, first of all, what we are doing is we are looking at the groove welds. So we can detect groove welds. So you see the coordinates and the groove welds. And we found two things on coordinate 192.5 meters to 132 meters. So we saw that there was current leaking out of the pipeline, and we saw that there was a deformation of the pipeline, of the magnetic field. So basically, when they excavated it, and what we detected is that there was a metal loss feature, and we detected that metal loss feature as 109.5 meters, and we definitely pinpoint that. And there was a coating feature, what we call current leakage, but it was not exactly over the actual pipeline. It was into the inspection direction, so it was at 130 to 132 meters. So you see both of the pictures over there. So why is that actually special? Because that's a typical example of what we can do. There was perfect coating underneath the defect, but we can still see the defect and the coating feature. So The pipeline depth, the depth of cover at this point was 180 centimeters. It was a gas pipeline DN100, and the metal loss of the defect was 26%. So the dimensions where the confirmed the width were 5 millimeters, and the actual length were 13 millimeters. So we are very happy with the results which we can find at the moment at pipelines. So the last and the most important question for all of you, I think, is which pipelines can be actually inspected? So what is the system capable of? Where are limitations when it comes to pipeline inspection? So I can say every ferromagnetic buried steel pipeline can be inspected by our inspection system. We can inspect from 2-inch to 42-inch, so from DN80, we start off, and we can inspect pipelines with sharp bends, 90 degrees, it doesn't matter for us how sharp the bends are. Also, when there are two pipelines and it goes into one, it's also no problem. And when they are changing diameters in the pipeline, this is also possible with our inspection technique. So the pipeline pressure for us doesn't influence or doesn't actually not matter the quality of the inspection results. So it's no problem if there's very low pipeline pressure or very high pipeline pressure. And it can be also pipelines with or without being in service, meaning that if you have an empty pipe which you want to see if it's still all right condition-wise, you can use our inspection technology to go over and we can give you the results. So also the transported product does not matter. We have been inspecting all gas pipelines, water pipelines, crude oil lines. We have inspected also jet fuel pipelines and brine pipelines. So basically everything which is out there in the market and it's cased by ferromagnetic steel, it's no problem that we can inspect it. So the inspection is certified up to a pipe depth of 2 meters, and the pipelines can be actually inspected with or without cathodic protection. So we have had cases in the recent past where we actually inspected pipelines which had no coating. So I thank you very much for your attention. You can find us if you have any further follow-up questions, definitely on booth 24. So there will be our physicians, especially for technical questions. I will be present as well, and we can talk you through the entire inspection technology, the setup. There will be a lot of sample defects we have found, because just of the limited time, I tried to nail it down in this presentation. So thank you very much for your attention.